What if we could simulate the universe with a computer? Well, if we could, then it would obviously be a very powerful computer. Today, I will be telling you the computer stats that you would need in order to do this. First, we will have to find out exactly how much information the universe holds. In order to do this, we will have to put units for each measurement. Also, let's assume that files can be accessed one bit at a time instead of in bytes. Coordinates will be in Planck lengths, taking up a total of 210 bits. There will be a total of 11 particle types, excluding quarks since they serve no other purpose than to make up protons, and neutrons. These include photons, protons, Higgs bosons, Z bosons, W bosons, muons, taus, neutrons, electron neutrinos, muon neutrinos, and tau neutrinos, and this will take up 4 bits. The energy possessed by the particle would have 100 decimal points, will have a maximum of 10 plus 31, and will be stored in joules, which would take up 436 bytes. And finally, its charge would be stored in coulombs, and would take up 400 bits. Assuming that there are 20.867 E plus 80 electrons, 29.866895 E plus 80 protons and neutrons, 4 E plus 85 photons, 4 E plus 87 of all neutrino types, 6.6 E plus 74 of muons and taus, and 1.388889 E plus 64 Higgs bosons at any moment, then the universe would take up 4.242008463000000145833335 E plus 90 bits, or 4.3861339 E plus 65 yottabytes. Because the universe is constantly changing, this number would represent the amount of RAM you would need. Assuming that each stick of RAM is 32 gigabytes, and that each RAM slot has the dimensions of 30 times 133.35 times 3.81 millimeters, then the RAM would have a volume of approximately 256,091,427.047 cubic megaparsecs. Okay, and now for the SSD. Assuming that your PC documents a snapshot of every Planck second of the universe, then the SSD would just be the amount of RAM multiplied by 8.0788429 E plus 60, which would be 34 duodecillion 270 undecillion 590 E plus 151 bits. The resulting SSD would take up 2.0689224 E plus 55 cubic yottaparsecs, and by the way, a single yottaparsec is trillions of times larger than the universe. You might be wondering how good the universe's GPU would have to be. Well, the GPU would actually not have to be that good. This is because things like raytracing are done with the processor which processes the photons. The only reason you would need a GPU would be so that you can have a digital preview of the universe. So now, we come to the final question: how good would the CPU have to be? Well, first of all, the CPU would have to process a frame every Planck second, in order to properly simulate the universe. Each frame, the computer would have to update a total of around 1.2040008 E plus 88 particles. Each particle has to have their x, y, and z coordinates, their charges, and their energy levels updated. This would make for a total of, yes, I will stop saying the full number, I know it is getting annoying, amount of yottabytes being processed every second. So assuming that each nanotransition in our CPU is 10 nanometers wide, then your CPU would have to be 1.241089 E plus 28 gigaparsecs on each side, which is, by the way, 443 septillion times larger than the universe. I am not going to talk about the power source, because I already know that it is going to take many trillions of times more energy than the entire universe possesses to run this PC. But yeah, hopefully this video helped you on your quest to simulate the universe, and see you in next week's video. Bye.